stop writing spaghetti code. There are many ways you can make your code better, more readable, more flexible, and just more awesome. But in this video I will show you some tips that you can implement right after watching this video and transform your spaghetti code into a humble masterpiece. If you are interested in that, let me show you the world of cleaner code. First things first, naming of your variables and functions. I know that this might be obvious, but this video is aimed at beginners. Please don't name your variables like a, b, c, x or int1 or var or any other name without any meaning. Let's look at this example. Can you tell me what this function does? We have some list of maps that we iterate over and then we do some sorting. But what are the objects we are iterating over and sorting them? And why we only add them when they are higher or equal than n? You would have to analyze it for some time and probably look at the rest of the code to figure out the purpose of this function. But if we only change the variable names without changing the name of the function, we can see what this function does. We can see that these mysterious maps were just students, and the n variable was the minimal passing grade. We are checking if our students passed the class. Then we sort them by grades from highest to lowest. When writing your variable names, you remember to be descriptive but concise and avoid ambiguous abbreviations. And exception would be, for example, HTTP or other abbreviations that are used very often. In this video description, I will put a link to a GitHub repository where you can check out if the abbreviation you want to use is recommended. The same rules apply to method and function names. Here are some examples of bad names, and here are some examples of names you could use instead. If you find yourself naming your functions do this and that, or do this or this, you know that something is wrong. Your functions and classes should have single responsibility. What that means? There should be only one reason to change the class or function. In this example, we have a function that is processing our user. We validate data and then we format our user. And in the end, we print the details. This method does three things and should only be doing one. If we refactor this code and break down our method into 4 new ones, we can first of all clearly see what is happening, but we can also reuse them separately in other parts of our code. For this example, it might be a little overkill to, for example, make a method print user details, since it's obviously only a simple print line, but hey, it's just an example. And if we are on the topic of code reusability, we need to talk about the dry principle, so don't repeat yourself. In this example, we have two methods. One is for user login and other is for user registration. We can clearly see that these two methods have parts of code that are identical. Now, for example, I would like to change our user validation. For example, I want to check if the password is longer than, for example, 6 characters. If I wanted to do that now, I would have to change the code in these two methods separately. In this example, that is not that big of a problem. But what if you have, for example, 20 different methods and you have to change the requirement in every one of them? For example, you can make a mistake. For example, you have to check for these 6 characters, but you can always make a mistake and, for example, change for 60 characters in one place of the code, and then good luck finding it. So this is why in the situations like this, I would highly advise you to extract this part of the code and create a new method. For example, validate the user. As you can see, we can now use this method in both of our methods. So let's do validate user, username, password, copy this, and use it also in the login. Now, when I want to, for example, change the requirements for the validation, for example, make the username longer than 3 characters, username dot length more than 3. And now, both of these methods will require our username to be longer than 3 characters. Next step to make your code better is to decouple your code. What this means is to make your code more modular, flexible, and less dependent on other parts of the program you're writing. In this example, we are creating a simple user service that is managing our users. When we add new user, we validate information about him, and then we save him to the repository. And the instance of the repository created in the constructor could look something like this. What is the problem with that? First of all, we probably would like to use the same repository in multiple services. But the main problem is that our service is dependent on the implementation of the MySQL repository. What happens if we want to use different database? Both of these problems we can solve using the dependency injection. First of all, we will create user repository interface, because the only thing we really care about in our repository is that it can save users. We really don't care about the implementation. So let's create interface user repository and void save user. Now we will implement this interface in our MySQL repository, of course. And now in our constructor, we will pass the user repository, and we will change the type to user repository, and of course assign this repository to repository. Now we can use the same repository instance in multiple services, and we can change our database without editing the user service class, because user service class does not care about the implementation of the repository. It only cares that it provides a user saving method. In Polish we have this phrase, the less you know, the better you sleep. And it's certainly true when it comes to decoupling your code. Next tip for today is to use design patterns in your code, and especially two, in my opinion, that are the most important. That is the observer pattern and the builder pattern. I am planning to make a full guides about each of them, so I won't get into much detail about them in this video, but I will briefly explain the use cases. You can use the observer pattern whenever you have objects that need to communicate or update each other without becoming so tightly coupled. For example, event handling or real-time updates. One example of that is, for example, making a newsletter. So we have our newsletter with a list of subscribers. Our newsletter doesn't know and doesn't care how many or if any subscribers it has. It will work the same. That allows us to dynamically add or delete subscribers during the program running. You can use the builder pattern when you have a constructor that has many optional arguments. For example, we have our burger class. Every burger needs a bun and a patty, but not every burger needs a veggies or cheese or sauce. So we need to add multiple constructors for our burger class, or make one very big and pass a wall of nulls when creating a new burger, without optional arguments, which will get messy very quickly. And in this situation, with help comes to us the builder pattern. Instead of having multiple constructors in our burger class, we'll have only one that will get all our fields values from the burger builder. That looks something like this. Now, when creating a new burger, we have a full freedom to make our burger however we want. And we can, for example, add cheese, we can add sauce, we can add veggies, but we can also just add only cheese or only add veggies. Nothing is stopping us because we have full freedom to do whatever we want. As I said, I'm planning to make full tutorials about these two patterns, so if you don't want to miss them, please subscribe to my channel and click the notification bell. YouTube thinks this video is worth watching next, and till the next time, create some amazing applications.